What's up guys? Today we're going to be doing what is probably the most useful video on my channel, especially if you do GCSE further maths. We're going to be going through trig identity proofs we're going to be going through them, and we're going to be going through how to work them out without just throwing random stuff at them or just giving up instantly. So to start, I want to clarify that these are 100% the hardest questions you'll see in a further maths paper. There's not going to be anything harder than this, absolutely not. So like when people see these questions, all these questions you see on the screen, and they just look away, they just flick the page because they know they're not going to be able to do them. But shouldn't be the case. They are difficult, but they're not just instantly flick the page difficult. So we're going to work out how to do them. So firstly, what is fates? So I was looking through like half an hour before I started this, and I was trying to come up with an acronym for how to solve these questions, and I came up with fates. It is factorize for F, A is algebraic fractions, I is identity, T is tan, and S is special method. The I means the sine squared plus cos squared equals one identity, and then the tan obviously it means the other one. Do it backwards. So when you're looking at a question, think of a special method first, then tan, then the identity, then the fractions, and then the factorize. Alright, so let's give some examples. So for factorize, for this one you can factorize sine out, just to make it more simple. Algebraic fractions, you can multiply. There's no identities in this. It just looks more complicated because there's trig involved. But if you replace these with x's and y's, it wouldn't change anything. For identity, this is where you actually use the identities, but it's still not that difficult. You're just changing the sine squared into 1 minus cos squared. Alright, next for tan, this is one of the most important ones because people just leave tan in for no reason. And a lot of the time, the examiners love to use sine, cos, tan together for some reason, even though it just to make it look more menacing than it actually is. And then for special method, I have an example here with difference of two squares. So we have this scary looking expression here that can just be simplified down into this, and everything cancels out. Right. Just take a few seconds to look at that because it is actually the method is complicated, but if you can get it down, it stops you from having to expand and then cancel more. So it's really useful. Alright, just going over some more special methods. So I've already told you about this one, but however, we've got some more. So we would just put this proof up from earlier. So next, the other way round is also important because you're going to see conjugates like this a lot, where it's like rationalizing the denominator, the harder ones, where you have to use the conjugate, where you just do the minus and the plus, and you switch it around to cancel out the some of the stuff from the double bracket, like this. And next, this comes up a decent amount with tan especially. 1 over a fraction is just the reciprocal of that fraction. Like this, 1 over tan is just cos over sine, because it's just the opposite of the identity. Alright, now we're going to go into some questions. I've got the fates on the screen, I've got identities on the screen. Just to help, make sure you try the question first, and we'll get into it. So firstly, with this one, you think about it, there isn't really any special methods, but what we can do is get rid of tan. So we're going to do that, and then we're going to move it to the top. We're also going to do algebraic fractions with the second bit. We're going to turn it into a fraction so we can get them both on the same fraction. Next, we're going to factorize the sine out, or 2 sine for that matter, and then we're going to cancel out the sine squared plus cos squared because that just equals 1. And that just equals 2 tan. Alright, next, this is a type of question where a special method is extremely useful because you could literally just expand this and then identity, and then that's the answer. That is 4 marks that you've easily got, considering that the last question was 3 marks, which was a lot longer. Alright, next question. Got a couple left. This is one of the last questions of one of the booklets that I went through, so it's quite difficult, but again, not impossible. As you can see from the bottom of the fractions, you can see that there's probably going to be some sort of difference of 2 squares cancelling, or like some conjugates here. So we're going to multiply them all like we do for rationalizing the denominator, and then we're going to put them all into one fraction and expand the denominator. And now you can kind of see from the numerator that a lot of this stuff's going to cancel now. So we're going to expand it, distribute the negative, and then cancel everything out. And then this just equals tan squared because of the thing I mentioned earlier. Alright, next, this is the final question I have here. Not too many questions because I was already doing stuff before we did the questions. This is definitely the most difficult question here because there's some weird algebraic fraction separation stuff you have to do. But firstly, we're going to realise that 1 plus tan x squared is tan squared x plus 2 tan x plus 1, because that's what we're going to need to get to in the end before we factorise it. Right, now we're going to go back to the expression that we actually need to simplify. We're going to separate this fraction here in just so we can work with the one on the left because the causes cancel out. And with the one on the right, you will need to turn the 1 into sine squared plus cos squared because there's not enough in this expression to turn it into 3 terms, like we need to factorize it into what the question wants. So we're just going to have to spawn the sine squared plus cos squared out of the 1, which is something that you should kind of have to look for. But not unless it's like a really difficult question. This shouldn't happen too much. And then you can separate the fractions again and then simplify them down, and then that is our answer. Alright, thank you for watching. Hopefully this helped with your trig identity questions, and I hope to see some people actually gain some marks on these questions, because every single year when they come up, no one gets any marks because no one has any idea what to do. Thanks for watching, and see you next time. Goodbye.